Okay, so in this video, we're gonna do friction on inclined plane. When an object is placed on an incline, that will be a slope, or it's friction on a slope or friction on inclined plane. This is the horizontal line, and a plane makes an angle with the horizontal. This is the object, and the weight of the object is acting from the object then straight down. Now, a weight, if you still remember on a horizontal, a weight was always perpendicular to the surface, but now the weight is not perpendicular to the surface. Now, let's look at this sketch here. This is the plane. It makes an angle theta with the horizontal. This is where the object is, a weight from the center of the object, gravity acting on it. So this is W, which is equal to mg. So this weight is no longer perpendicular to the plane. It is an oblique force at an angle. Now, if it is inclined, we need to resolve it into this component and this component, horizontal and vertical component. This angle here is equal to this angle there. This component and this one. So we use SOHCAHTOA to name this component. One of the component is perpendicular, the other component is parallel. So when we use SOHCAHTOA, this is adjacent over hypotenuse, right? So adjacent over hypotenuse will be cos. So this component is FC, which is equal to F cos theta. So the F we are talking about is W, the weight of the object. And this one is opposite over hypotenuse. And opposite over hypotenuse is sine. So this component here is Fs, and it is given as W sine of theta. Now, when you close a parallelogram, this component is equal to this one, and this one is equal to this. So we're going to focus on two components that are attached on the object, which will be this component and this component. So we transfer this Ws to this side. The Fs will be equal to W sine of theta, two components. Now the weight, the normal force is equal to and opposite this component. So you extend this component this way, this will be the normal reaction force. Now, if there is no external force acting, to keep this in balance, a friction has to oppose this way. So a friction will be acting in opposite direction. Now, if we can apply the equilibrium conditions, or the forces that are upward are equal to the forces that are downwards for this diagram, we're going to have sum of the upward forces must be equal to the sum of the downward forces. Now you look at this diagram, you can tilt it like this so that you can see what is upward and what is downward. What is upward, if you look at this diagram? The normal reaction, that's correct. And what is downward? Remember, a weight is replaced by two components. So what is downward? This is downward, So FC, sorry, is this component is FC. So FC is downward. So NR is equal to FC or WC. So this NR will be equal to FC is W cos of theta. Now, in some questions, you cannot be given the weight, you can be given the mass of the object. So to change from mass to weight is W equal to mg. So that's why some textbooks, they have NR as mg cos of theta, because W is equal to mg. Now, if we do the forces that are parallel, to the plane. Forces to the left are equal to the forces to the right. This is to the left, ne? So Fs is equal to, this is to the right, ne? Frictional force. So if friction is not given, friction is given as mu r nr, ne? So if we can put mu nr where there is friction, and Fs is W sine. So we put W sine here equal to mu multiplied by nr. So this W sine will be equal to mu multiply normal force is equal to what? Is equal to W cos theta. So it will be times W cos of theta. So when we divide, it will be W cos both sides, W cos both sides. Cancel out, W cancels W. What is sine over cos equal to in maths? Sine over cos is equal to tan theta, ne? So tan theta is equal to mu. This theta is this angle of slope, ne? So is that angle is called the angle of rest or angle of repose, theta. Now you still remember when we were doing the horizontal surface, that we also got that tan of phi, which is angle of friction. It was also equal to mu. So angle of friction is the one that is between the normal force and the total reaction force. So angle of friction is the one that is between the normal force and total reaction force. So these two angles will be equal. If you can be given coefficient as 0,4, it means the angle of friction will be equal to the angle of phi of rest, because this is the same. So this angle theta and angle phi are equal only if the slope is maximum. So at maximum slope, or we can say it's a maximum friction. So if a question mentions that the slope is maximum or the friction is maximum, angle of friction will be equal to angle of rest. They will be equal. Now let's look at the activity. The example that will involve the inclined plane. This is the theory based on inclined. Now we can solve the questions or can answer the question. Now on inclined plane, the applied force is pulling downwards. If the question says calculate the smallest force that is required to pull the object down, you sketch your diagram, you show mg sine or w sine, w cos, the weight, you show that ft downwards. And the friction always opposes the motion. And you're gonna apply the forces up the slope are equal to the forces that are down the slope. But if the question says calculate the force that is pulling it up, you go to your diagram, you add your Ft up. But friction always opposes the motion, it changes to downward. And you apply that condition that forces that are downward are equal to the forces that are upward, and you make Ft the subject. So I'll look for the activity that we can